Hello and welcome to Nimrobotics. Today is our podcast with Dr. Ronak Mohanty, who is a research scientist in the neuroeconomics lab at University of Wisconsin Madison, and he'll be soon joining Amazon as a human factors engineer. So today we'll like to learn about his career trajectory and everything he would like to share. So welcome to the podcast. We'll start with a quick introduction.
Thanks, Akash. This is my first podcast ever. So I'm really excited, but I'm also nervous at the same time. It's been a while since I've had this kind of conversations on video. But yeah, a brief introduction about me. As Akash mentioned, I'm a research scientist at the neuroeconomics lab at the University of Wisconsin-Madison. I mainly work in the areas of human-computer interaction, human factors, and AR and VR for healthcare, public safety, and engineering design applications. I did my PhD in mechanical engineering at Texas A&M University, following which I worked for 2 years at Meta Reality Labs. And as my next career path, soon going to start to work with Amazon as a human factors researcher with their devices and design group. So yeah, that's about me.
Awesome. That's really exciting career trajectory. We'll get very personal in this podcast, so feel free to skip questions. But we'll start with,
Okay.
so as a kid, what would you wanted to become, and how close or how far are you from where you wanted to be?
So that dream still stays alive is that I wanted to be an automotive designer. Like, as my friends remember me, everybody remembers me that I used my notebooks from school were full of car sketches. And I think I'd still till date, when I am distracted, I just want to take a break, I start sketching a car on my tablet or on my notebook. From a career point, I think so I did go to grad school, and in my undergrad, I did design focused work. But after coming to grad school, I realized that there are two options for me. Either I can be on the applied side, create some designs for new products, or be on the back end where I understand the needs of the designers and then create tools that make lives easy for designers. And that's what I chose, that okay, it's much more exciting to actually create these new tools, because it's not only going to help me but also going to help other designers like me. And maybe in the near future, I would like to explore the option of doing some human factors and HCI kind of work for the automotive industry. And as we are slowly moving focused on user-focused infotainment systems and dashboards, that I think is an exciting space where maybe a couple of years down the line, I would like to see how it goes.
Awesome. So when you say you wanted to be in design, I don't have a lot of background in design, so I'm wondering what does design mean to you?
So yeah, for this dream of design was before even I knew what engineering was. For me, it's purely the design, like how the car looks in and out, and how the design flows from an aesthetic standpoint. Like, the first thing I look at the car before even we dive into the engineering, that's the visual appeal of the car itself is what draws it to, which draws you to it. So that's where my goal of designer was. That engineering was not even until I did my undergrad, where I did actually build an electric motorbike. But again, that was, I would say, probably one of my initial forays where I did the designing, the CAD modeling for building that bike. But otherwise, it was purely from an aesthetic or the visual standpoint.
Awesome. Yeah, I think it's really nice to see your imagination come into the CAD. Going back to the career academic trajectory, so Ronak did his undergrad back in India, and then he did master's and PhD in the US. What are some key differences that you see in academia in India versus the US? What are the things that strike out?
I think that's actually a very good question. It could have multiple perspectives, but for the beginning, I would say that the level of seriousness, or maybe I would say the structured approach. So when I came for grad school years and when I TA'd different courses, I saw that there was a particular structure to undergraduate education in the US, which I realized had I had that exposure during my undergrad, it definitely would have made the initial years of my grad school very easy. For example, like one thing I still tell to everyone who are in core departments like mechanical engineering, civil engineering, and chemical, that programming is not meant for computer science people. It is something that everyone should learn. It's interdisciplinary because we are in the age of computers where everything is done through computing devices, whether you like it or not. And knowing some programming language definitely makes it easy. In my undergrad, unfortunately, I was one of those people like, oh, I am mechanical. I don't need to know programming. So I never paid much attention to it. But when I started grad school, I realized that that was a mistake. But here, when I saw that from early on, at least people get some experience using MATLAB for starters, and maybe I think they are using Python now. And once when I recently went back to my undergrad, which is KIT University in India, they also have started teaching programming to mechanical engineers. So that's one of the major aspects is this difference of education structure. Here, I think most undergrads follow a very similar structure in terms of how education is imparted. In India, it is very dependent on the institutions. If you're one of the IITs or the NITs, they have a common structure, but when you go to a private university, and sometimes that that actually impacts the motivation of the student. For me, since I wanted to be in the automotive field, I took that initiative. My senior design project was to do some emission testing for an IC engine, and we also created an electric motorbike. But otherwise, a lot of my friends in undergrad, they unfortunately they haven't continued on the path of mechanical engineering. They have all gone to different areas and they have found their interest and their passion, which is great, I would say. But had this been imbibed in us early on, that would have helped.
I think I got lucky with this one. I think it was a requirement for everyone to do the one course in probably the first semester, I think, no matter where you are from. Also, even before that, in the school, we had a choice between 2 or 3 things, and then computer science was one of that. And to this day, I still use the concepts that I learned there. And okay, it's kind of surprising. Like, it was really in depth for like high school. That really helped me.
And I agree with you because my friends who had their schooling in the CBSE board, they definitely had that exposure. Unfortunately, the state board, at least the Maharashtra state board, did not have that facility. So yeah, that's where I think also because the difference of boards in India, that also creates an impact on when you actually in my 11th and 12th grade, we had that option to choose a vocational subject. I went with electronics, but we also had people who did the computer science. So maybe if I would have taken computer science back then, as this, I could have had a similar exposure as you are, but we did not have it as a mandatory subject to go through.
I see. Okay. So now that everyone's talking about AI, we have LLMs integrated everywhere. How do you think that could impact some of these shortcomings? What do you think about the education plus the LLMs?
I think AI is definitely great. I would not discount that fact, but at the same time, I also feel it's a double-edged sword.
Yeah.
Because our schooling probably has like 7 to 8 years of difference, right? So for us, we did not even have like machine learning and all. Everything was purely by search, by books on Google, and that's how we gathered information. Maybe most of it was for you also. For the current generation, they do not need to go through the multiple steps of trying to find information, because AI, you ask a question, it takes care for them. So somewhere although they are getting more efficient in finding information, but at the same time, it is like, it's very tantalizing. It's a very, I wouldn't say like it's like a drug, but it's kind of addictive that when you're getting information for free with so much ease, then you kind of feel like, oh, this is how I can get through. But that does not, it may provide you the information at that point, but it does not teach you. You do not learn from it. And that motivation for learning still remains unsatisfied or incomplete. And that's where I think nobody has, all the people have discussed this explicitly. There still hasn't been a structure as to how we can curate this, that, okay, while AI helps you be more efficient, but at the same time, we ensure that there are some things that are done the traditional way and the students learn and imbibe all the knowledge and build very strong fundamentals.
Yeah, I think the key challenge will be like if we have general task, we can always use it and we always get good accuracy on the regular or usual coding task, for example. But then if you hit a problem which is not very conventional, and because the person has been using LLMs their whole life, they will never be able to help or work on that problem. So it's more like the more better the autonomous car gets, the higher the challenging it gets, because when it fails, you cannot take over.
Exactly. And it's also think like you and I both, when we talk about, okay, we want to do a certain statistical analysis, we have this process of doing a normality check, looking at the spread of the data, plotting the data. But so we do this step by step. We have done the search, looked at Stack Overflow and different resources. We have looked at papers. But for someone whose code is being written by AI, for them going forward, they're like, oh, I don't need to do that additional search. The AI can just get the code written for me. Yes, you can still get your task executed, but really, like when you move forward in your professional career, that is going to be a big risk, because when you're interviewing and also when you have to look at some core issues, you cannot completely rely on AI. And also most companies are not comfortable with their employees using AI to debug issues that belong to the company, because that violates the data privacy, although they have their internal AI tools. So that dependency is kind of like a double-edged sword, and yeah, I hope a resolution comes out for that, for people, so that it still like fosters learning, but also makes learning an easier process than a time consuming.
This really poses challenges for the educator, like how do they design, how do they evaluate students? In some sense, we also need to provide education to the educators.
It's going to be a tough challenge for educators for sure, because then the question is like, do you spend your time trying to find the policies of AI and then design your assignment around it, or maybe put some restricted, or maybe design your assessments in a way that it counters if someone has heavily relied on AI to solve the assignment.
Yeah, I was recently talking to a professor on the use of AI for writing proposals. For those who don't know, proposals are basically how people in academia get grants or money for their projects. And I think I really liked one thing he talked about is how if we allow people to use AI as much as they can, that removes the barrier in terms of language and writing. Some people might not have same level of fluency, but their science is excellent.
Right.
While other people might have poor science, but amazing fluency or writing skills. And the people might end up choosing the poor science with good writing versus the best science versus with bad writing. So it kinds of help with that.
I believe that a good balance is needed, because if there's amazing science, but it's not presented in a clear way, I don't want it to be a very Shakespeare or very polished English, but if it's something that's clear enough to convey that message, yes, definitely I think it's a great tool. But at the same time, we should also train ourselves and fellow educators on removing any biases that may have, and be aware that, okay, even if AI is used, but is there science original? If that's not been, if what they have shown is not synthetic, but actual experimental data or actual contribution, then why not give them that benefit? Right. So I think that is
Yeah.
where like AI with proposals and with scientific papers, journals, I think is a useful tool. But again, over reliance on anything is detrimental.
Right. Yeah, I think my personal understanding right now, the human should be held responsible
Yeah.
for whatever thing they are submitting. So that's my thought, because it's a tool. Of course, you can use it, but then you should be responsible for the content too. And given that it will produce good looking content, which might not be correct, that makes it important for the human to be responsible. I will take a step back from AI. I'll go back to the career. So I'm interested to know what motivated your PhD thesis work and your overall PhD experience.
So, okay, I wouldn't sugarcoat this, but I think every PhD dissertation comes together when you start writing it close to your defense. Until then, it is loosely associated different projects that you have done to prove different hypotheses. But only once you start writing that story, it kind of starts making sense. So my journey at Texas A&M was that I came as a master's student in the spring of 2015. I joined a professor in the Department of Engineering, Technology, and Industrial Distribution. And because I could not, the only design faculty who was there, she had just moved to Georgia Tech. So the closest thing for me was to get into manufacturing. So I started working in the field of additive manufacturing. I worked for I think a spring and a summer with the professor. And then my PhD advisor, he joined, and one of the new students reached out to me asking like, hey, do you know about this professor? And that's how I learned about it. And I reached out to him, spoke to, and that research sounded actually much more closer to design than what I was actually doing with the previous professor. And after that meeting, I decided, okay, why? So I still remember the first conversation we had. So his goal was to create something like Jarvis from Iron Man, to have like that AI assistant, which not only gives you like responses, human like responses, but also performs tasks on your behalf, or maybe assists you to make those or make different spatial interactions much more intuitive and easy. And he wanted to do that for design. So that's how I ended up joining the lab, which was also an interesting process because I had to develop an Android application, which I had remotely done way before, but something, and just show it to him. And the next day he offered me like, okay, would you like to join the lab? And after that, we brainstormed, okay, how can we help? So one of the challenges in design was that we traditionally do the ideation on pen and paper. Then we start doing 3D modeling, but humans inherently think in 3D. So I started with how can I enable users to create 3D sketches. But again, the challenging is on pen and paper, you have a physical surface that gives you that feedback or a normal force, I would say. But in 3D space, there's nothing. So I went with the route of haptics or touch perception, specifically force feedback, and ended up designing few algorithms and tested them for haptics versus no haptics. We saw almost like 50% improvement in performance for the users across different tasks, and explored that initially across sketching and some 3D modeling interactions, and realized that there are two key aspects to it. First is that science till then hadn't explored how to evaluate precise. How first we saw that users are using, they were dividing their tasks into precise tasks and some coarse motor tasks. And until then, science hadn't studied in HCI, or in those work, people hadn't studied that. So that was one of the phases of precise motor tasks. And the other one was there are no existing metrics. Every metrics is purely task completion time or error and everything, which does not talk about the innate human behavior while performing these interactions. So that's how my dissertation then, I started with the 3D sketching, For the metrics, I worked with orthopedic surgeons at the UT Health Science Center in Houston. We ended up creating a hybrid training simulator, which I recently spoke to the surgeon I worked with, and he mentioned that the training errors have reduced by about 40%. And now they're using that system to train the first year residents. And we also developed novel metrics. We were able to create some movement signatures that clearly showed the distinction between a novice first year resident versus an expert surgeon who has decades worth of experience. And the other project was finally to compare if you co-locate your visual and motor space, because that's how precise motor control is performed. And if we do that for mixed reality applications, does that improve task performance, but also does it enhance the user experience? So that's how my dissertation, it was called proxemics, just to understand the visual motor co-location. The analytics was the metrics, and the kinesthetic was the force feedback. And that's how my dissertation, I would say, came along at the end, really. But it was not, I did more other projects also that were not a part of my dissertation, but these three things made the core of my work. And I would say it was a great experience to get the taste of different areas, and not only the depth, but also the breadth of the research.
I think it's really exciting to know that some of your work is being used in the real world, because most of the time the PhD work to the application timeline is really, really long. So that's really motivating.
Yeah, that was an interesting work because we did that in peak COVID. So in the beginning, we did some trials in the lab itself, wherein we had to follow the protocols and we had to ensure that it does not overlap with other, it was a shared lab. And also if we went to Houston, which was 90 minutes away, we followed protocol. Sometimes, because we had to take data for experts, because experts were difficult to find, and they were on-duty surgeons. So there have been instances where we have gone to Houston, but no one has showed up. So that was a challenge, but I'm glad that we were able to get some data and create some metrics and provide that simulator that was, I mean, the idea was that they did not have an objective way to evaluate. So I came up with a dashboard that showed different metrics like force, acceleration, their 3D motion, but also they could do like a comparison with the metric, the signature that I created, and compare how is a novice surgeon's performance progressing across different years of residency when compared to an expert surgeon.
So there are some really cool applications, and so close, like the gap between application to.
In hindsight, I think it's cool. In that process, I was just like a student. I'm like, okay, this. Sometimes I felt this is interesting, but now in hindsight, when I'm connecting the dots, I'm like, oh, this was a fun project to work on.
Yeah, I think your career trajectory has been like really amazing, because you went to industry and then came back in academia and then are going to industry again. So how do you see the two? Are those two separate realms, or do you think they are more similar to each other than people think? Or why thoughts around work-life balance or other things in both the domains?
So for me, my goal was to go into academia, and that's how I aligned my training during my PhD. Also, I got the teaching fellowship, so I taught a course. I TA'd multiple courses. By the time I graduated, I had about 13 papers, out of which 8 was first author papers. So I had ensured that I had a good profile, but also the thing is, I was coming from a very new lab. So that made it very challenging to actually find postdoc opportunities. I don't know why I did not apply for faculty roles. Maybe I did not have that time, because I was one of the first students graduating along with my colleague. So we basically were the ones who set up the labs. Every protocol, everything that's in the lab right now was established or designed by us. So I did appear for one postdoc. Unfortunately, did not get any response from them. which was in haptics again. But then this opportunity came. I had interviewed for a human factors role, but the person who was hiring, they found me overqualified for that, but they referred to another requirement that was in the team. So this was a 2-year postdoc kind of a role at Meta Reality Labs, and again it aligned because I came from a haptics background, HCR background, had the experimental design background as well as applied perception, and the team I joined was also called the perception team. So that's where they went like it. I would say it was a great experience in the sense it was like the way I would describe is that imagine if all research labs in a university start working together. So a great thing was that I got to focus on a critical aspect of a certain product. That I mean, again, we were more on the fundamental side, so we were defining the fundamentals that would lead to the future design of product that was 7 to 8 years down the line.
Can you talk about the product here? But there's
So I think it's you would see the haptic gloves that Meta has announced or the wristbands they have announced. So those were the kind of products that we were working on and different kind of haptic feedbacks that we could create for them. And we would work with different teams like you're working with the hardware team who are actually designing the actuators and coming to you and saying like, hey, can you do like a perceptual evaluation for us and find the right set of parameters that would be human perceptible, right? So that was they don't want to over design or over engineer something. Then you work with the software team so that they design the study interface for you, and then you're like, can you design this kind of study interface for us to evaluate the user experience? And then I was working on glove and wristband, so there are different aspects to it, and again you have to see if there's a certain aspect of the work that you can publish, can you present if it does not have any IP issues. So for me, it was again going back to academia without the pressure of academia, because yes, we did work extra hours sometimes on weekend, but it was, I would say the timeline was much more spread out than doing a PhD. And I would say that then, and once that 2 years was about to end, market, as we know, was not great around that time. And I didn't want to take up a job that did not include research in it. And I really wanted to be in this field, and that's where I, learned that Dr. Mehta is hiring postdocs or research scientists for the lab, and she wants someone who has expertise in AR and VR, which was my background, and also maybe haptics. And I would say the last year and a half working in the lab has been great because I have been able to start new things, see that go through, look at the results and see like, oh, this has actually worked. And now, while I'm about to leave, we have taken those feedback of the initial implementation of the project and now building the version 2.0 of that. And soon that will be evaluated too. So yes, I would call this like a very like startup like experience, because we had a set timeline. I had to form my team. I hired undergrads, collaborated with some grad students, and eventually we were able to deliver a VR experience to train police officers again. I have not worked in that field, so it was a great learning experience.
Yeah, so kind of a different experience working with people in different domains.
Yeah.
I worked with emergency responders, and the way they operate is slightly different than how we operate.
Yeah.
So there's a lot of things to learn.
And it's very challenging, to be honest, because as I mentioned, I think my experience with the surgeons taught me that, okay, they are active duty people. So you really have to collaborate. You have to work around their time so that, but again, you need their experience, their information, their feedback, because whatever you're building is for them. So that I definitely believe was a really great experience. And hopefully in the future, if this gets implemented, I would love to see the outcome of that.
So you talked about how you're interested in academia, but then you had to go to the industry. That's how the opportunity showed up. So do you think given an opportunity, you would choose academia over industry now? Uh, Given an opportunity.
So when I was graduating, yes, I was dating my like now wife. And back then we did not have that foundations of a location. But at the current phase, as a student, I wouldn't have thought about this or cared for this. But now, like almost 4 years after my graduation and at a different age, maybe age, and like whatever, at a different age, I would say that different things or like personal life is also taken priority. So that comes down to work-life balance. It's not that I want to work for 9 to 5 and then spend time at home. For me, it's like, yes, I'm happy working like, because I love the research, love the space, I'm happy to work. But also, I would enjoy my work more if I'm doing that in the presence of my loved ones.
See, yeah, I think this is kind of a challenge that I never thought about. Is like academic positions are very scarce and they can only happen at certain specific positions. So
Also, location.
yes,
Location is a big thing because academia, as we know, it does not pay as much as industry. Some universities recently do, but it pays good enough for that location where they're hiring for. But again, let's say some universities like UT Austin or the University of Washington, they're hiring for cities like Seattle and Austin. There, maybe the faculty salaries may not match the cost of living in those societies. So that also becomes a challenge. But again, if you are with a spouse or a partner who is not in the academic domain, but they are in different space, finding jobs becomes a challenge. Like maybe Madison is a great place to find jobs, but let's say someone goes to College Station, that becomes another ball game, another challenge, especially with companies scaling back on remote work. Right? That adds another layer of difficulties that the couples have to tackle. Well, try choosing between academia and industry. And I would say my current decision. So last year I had almost decided on where I want to apply and the name of my lab too. But eventually I realized that I had to either choose to take that path of academia and again wait for 5 years for tenure and see how things fall, or maybe spend some time with family now because I had lost, I think, the pandemic and also due to how demanding my work was. I did not get to spend much time with my family. So I really wanted to focus on that side of my life. So that's where I decided to, okay, I'll go back to industry, but again, in the human factor space is great because that's what I love to do. And in my new role, I will actually be setting up a new lab. So it's not different than academia.
with the higher pay.
With a higher pay, definitely. But I would also say, like, talking about academia and industry, in the beginning, who is starting, it might look like different. But once you start working in that space, it's not very different from each other because there are stakeholders in both spaces. You have to convince your PI, there you have to convince your manager. You're working with external collaborators, but within the company.
But I think if you are a PI, you have to also worry about money, which is an added.
That is true. That was a constraint. But again, I would say if you're working in a startup, they also have to worry about how much you're spending. If you're talking about big tech, yes, they have funds are much more disposable for them compared to a big research lab.
I think one question I have is for me is sometimes I feel like when you are in academia as a professor, sometimes you get way too far away from the things that bring joy, like really doing things hands-on, and you are more focused on just applying for grants and getting the money, and you cannot have time to really go and get your hands dirty. So what do you think about this challenge?
Because I've seen that because I was one of the first 3 students of a new research lab during my PhD. I think of a professorship more like running a startup. The university pays you a startup fund. You hire people to do some research ideas. But again, like every startup CEO, which the role the PI plays, your role is to make the company or the lab afloat. So if you focus on getting the work done, you cannot network and get the funds. And what you need is the funds. So that's where, but I would say on the brighter side, compared to industry, you have control of what you're working. Even if you're not hands-on, and people can still do the programming and everything, whatever they like to do, any kind of thing that brings them joy, but you still have control of what you do. That is where I think, yes, more money in industry, but less control of what you want to do. So I think that's where you decide whether I want to take that slightly, I mean, it depends, like me, let's say like a substantial pay cut, but enjoy what I do and have control and not worry that, oh, someone over me is going to reprimand me or going to fire me just because I have underperformed, versus taking that big paycheck at the end of the day, but also be like, okay, I want to do this, but this does not align with the goals of the company. But that's where I have to make that compromise. Okay, this is what I want to do. But again, there you can still make significant contributions. Yeah. So that I think those are the two pros and cons of being in industry and being in academia. I would mainly say the control of your interest in the work you want to do is where the significant difference lies.
Yeah, that's totally true, but also really tricky to think about sometimes.
Yeah, yes, definitely.
Well, on a
But
bad note,
I would like to add one note too. I know someone who was in this in my organization. They did their PhD and postdoc from UC Berkeley, joined as a research scientist, worked for 2 years, went back to becoming a professor at Georgia Tech. So, and not only one, but I know multiple folks who did that. So that's also, but also on the flip side, there were many new assistant professors who still had their lab, but also working as research scientists.
yeah, I think a lot of people especially in the computer science domain, they do that. I think the collaboration is a little bit easier, I guess, given how fast the industry is moving.
Yeah.
They should.
The industry has realized that you cannot, so if you want to bring innovative, real, like life-changing products, you cannot solely rely on engineers and software developers. You need researchers who will help you resolve or at least identify those core questions and find solutions to them, which helps you build those products.
Yeah. On a side note, I would like to hear what your potential lab name was. Is it the Mohanty lab or
no? I will have to look for it, but I definitely had that. No, it had. I think I had discussed that with Dr. Mehta also. Yeah, maybe I'll find it and let you know. I did have a. It was not called the Mohanty Lab. I had come up with a cool name for it. So yeah, maybe once I find it, I'll let you know offline. Yeah. Actually, no. Let me. Okay. Yeah, I think I have it here. 1 second. It was called the I Create Lab. It was called the Interactive Computational Research and Engineering for Advanced Technology and Design.
how do you come up with so much creative acronyms?
I think I started with it, took some help from AI for sure. But yeah, and it's maybe just like how Dr. Mehta here in this lab does. In my PhD lab, we used to think of very catchy names that would.
I have a capstone team working with me, and they have this thing called "I Trust You." Trust.
Yeah, it was a really cool name. Yeah,
Interesting.
like the project we have right now is called AI Expert, like AI extended reality project for non-enforcement training. So,
do you find any? Well, I guess you have not worked in India, but are there any significant cultural differences or challenges that you have faced over time, or how do you connect back to your Indian roots? Are there specific activities that maybe do you like
professional or personal?
Personal.
For me, I think it's movies. I'm very much in touch with Bollywood. So
what's the last movie you watched?
I watched it was called Chhawa. Yeah. So Vicky Kaushal movie on Sambhaji Bhosle from the Marathas. So I saw that a couple of weeks ago. Yeah. Although I equally follow English series and movies, but I do find my comfort in Bollywood movies, and in Bollywood, and even like new like Indian TV shows, which have improved significantly from what we used to see as a daily soaps on television. So I would say they are on par with any international show. So I think I really enjoy that. That's my guilty pleasure.
That's awesome. You will be joining the Amazon as a human factors engineer. What do you think, or do you have any visions for human factors, where human factors will be in like 10 years from now? Do you have any personal aims for where the field should be focusing more on?
I think, yeah, that's I'm glad you asked that. So human factors, thankfully, so I think it's a bit not controversial exactly, but the currently it is like everything human factors falls under UX research. And the way people look at UX research is more qualitative, just doing interviews and focus groups and getting user feedback and surveys. What people don't realize is that user experience or improving user experience is not limited to those tools. Yes, they are great tools, but also about coming up with ways to understand and quantify human behavior with these products. For example, like let's say I'm using a foldable phone and you are using a slapped phone. On a surface level, these are phones. They do all the basic functions that the phone does. And maybe you can tell me, I'll ask you to write like some note. You would do that, on maybe I'll unfold my phone and do that. Then you can give someone a survey that, okay, like a user engagement scale. What did you find more user engaging? That just says that, oh, person using a fold phone found it more engaging. But what it leaves us longing for is the why. And that's why human factors, maybe you use eye tracking and see, are they scanning more on that particular screen? Maybe you look at EEG data and see they are if they are more frustrated while trying to type a long note on a candy bar phone versus a foldable phone. So that's what I think this what people think is academic research, but is actually very relevant to product, where you can show that not only to your stakeholders, but also to the world that, hey, it's yes, we got the user feedback, but we also have implicit data, which the user does not know and cannot tamper. And it shows that our product actually improves user experience. For example, Microsoft did this research with the Outlook. So what they did is they had participants go through continuous meetings wearing EEG versus meetings which had some duration of break. And they found that the brain activity reduced when they had a break versus their brain activity was continuously spiked when they had no breaks in the meeting. And they showed that that's what made them introduce this feature that when Outlook sets a meeting, it sets it 5 minutes off the actual clock. So that even if your meeting is ending, you have that 5 minute break to cool down your brain and like reorganize yourself before you join the meeting.
Is this feature already deployed?
I think it's because we had something like that at Meta. All our meetings were like started 5 minutes late.
I see. Maybe it's just admin level.
Yeah. Maybe at something like that. So that is where I would say, even for automotive, like sometimes I wondered, Tesla is amazing in terms of software, but when you're driving and you want to make those changes, the settings are so deep into the menu. Right. I cannot take my eyes off this. Even for adjusting a mirror, I have to choose something in the menu versus having a physical button.
On the same exact topic, I was watching a video today by Steve Wozniak, and he was talking about how he loves Tesla, but then if he has to even open like glove box, he has to like dig in and find menu.
That said, Apple actually does a great job because Apple's main, because I've used both Android and iPhone. Android, I would say, is for advanced users because it gives you a lot of customizability, but from the ease of use, user experience, Apple is amazing. And what they have given the world is a very key interaction, pinch to zoom. Until now, it's like second nature. Even small kids know that you just have to move the hand on the screen and it'll expand. But before that, all phones had was a magnifying glass. You pressed it multiple times to zoom in, you pressed it multiple times to zoom out, which gets the job done, but it's not a pleasing experience. So that's what I see, that human factors should be a separate thing than UX research. UX focuses more on the user experience. Human factors focuses on understanding human behavior and seeing those behaviors change as the products improved, like, like over the years.
See, awesome. So I think we are coming towards the end. I would have a few final questions. So what's the most rewarding experience you had so far in life? And this could be both personal or academic or professional, whatever you would like to talk about.
One thing I would say, two things actually. First, from a professional standpoint, my PhD, although difficult, I would say it gave me that confidence to take unknown things head on. I, like maybe most people out there, I still feel anxious, nervous when trying new things. But also, this thing that has stayed with me that my advisor told is fail early, fail often. Try, fail. And it's okay to fail. And that I want to say to everyone that your first shot or your first draft is not always the best draft. But until you have done badly or even just taken that action, you wouldn't know what to change. But if you think that your first execution itself is going to be the best one, that will never happen. And what it does is you eventually keep on taking time, that you think that, oh, I will prepare myself best and then do. But you can never be prepared 100%. You can never be anything that you, if you write something, it won't be 100% the best. All you can do is improve. So that I would say is a significant learning that I have taken from my professional life. And also when someone senior to you is giving us a feedback, even if you don't like it, it's not that they are criticizing you. They have your best interests also. So take that feedback, see if it actually helps you improve. And I think that has definitely helped me improve from a person who was a mechanical engineer, didn't knew jack squat about HCI or human factors, from starting to work at Meta. In hindsight, it just looks like, oh, how is this even possible? And from a personal standpoint, I would see that having your family's support, having friends around you who are supportive, because when I was given the option, I joined as a master's, but when my advisor was like, do you want to do a PhD? My parents were like, it's a great opportunity, you should think about it. My friends were like, my best friend was like, dude, nobody gets that kind of an opportunity. You may not get it in the future, so why not take that chance? And my wife, whom I just started dating back then, she told, I don't want you to take a decision based on me, because in the future I don't want you to regret if things don't work out. So I think all those things, having them as a support was really, really helpful in making me survive my PhD, also tackle these changes in the career trajectory. So that, and oh, one thing I forgot, having a great mentor. So my advisor was a great mentor. I have my manager at Meta was a great mentor. Dr. Mehta here is a great mentor. Hopefully my next manager is also a great mentor. So that mentorship, seek for mentors. Yes, you can do things by yourself, but seek mentorship from these people, and because they have seen both the goods and the bads, and yes, you may experience them also, but sometimes, as I said, you need not reinvent the wheel because someone has already tried to do that and they have failed. So that's why the mentor plays a very critical.
Yeah, that's really awesome. And the things that you just talked about also apply to this podcast. This will improve heavily over time. I'm just trying and failing, but we will see improvements.
No, I mean, I think you, just to give a huge, Shout out to Akash here. I think he is an example of fail early, fail often. He tries, he fails, but he improves. And I would say that I would love to have the confidence that he has. So definitely people who are working with him should take inspiration from him. That try. There's no harm in trying. And go with confidence. What will happen? It won't work. You're not going to die.
I think the most important thing I have learned is no one cares. So
Exactly. People care. It's how no one cares.
you should not. Yeah,
And you should not
much
care
about
about
fail-
people
failures.
just criticizing it, but care about that. Okay, I'm learned. What lesson have you taken from this?
Yeah, I think we'll close with one final. What's your final message to the world?
Final message is that life will always be full of problems. It's just the problems keep getting better as you progress in your life. That's what I think.
Awesome. Thank you so much for talking to us. Thanks for being your nice. It was great. And we'll catch up. I hope already recorded.
Thank you.
Thank you so much.